Yeah, hello everyone. This is a question from JEE Mains 2026, 28 Jan evening, and you can pause your screen and go through the question. Um, so the question is saying we have to plot log 10k versus 1 by temperature. So I mean they have said that it's a straight line. They're asking us the intercept and the slope, and k is given to us as the equilibrium constant. Okay. Now, the chapters involved in this question are equilibrium and thermodynamics. Okay, so let's proceed. We know that according to thermodynamics, this reaction is delta Rg is equal to delta Rg naught plus RT ln Q, where we will understand the meaning of each and every term. Delta Rg is the change in Gibbs free energy of the reaction at any state. Delta R G naught is the change in Gibbs free energy of the reaction at standard state, because a dot or a naught is involved. R is gas constant, T is temperature, and ln is logarithm base E, and Q is the reaction quotient, right? Okay. Now, in the question, we can see that they are talking about um, log 10k. That means they're talking about equilibrium. So therefore, we'll focus on what happens at equilibrium. So at equilibrium, we know that delta Rg is equal to 0. That is, the change in Gibbs free energy of a reaction is 0. And we know that the reaction quotient K is equal to Kp or Kc, depending upon you are expressing the concentration or the partial pressure. So here nothing is mentioned, so let's take Q in general as K. Okay. Now, when we substitute these values into the above equation, we get that 0 is equal to delta R G naught plus RT ln K. Nice. Or I can write delta R G naught is equal to minus RT ln K. Okay. And okay, so this is an important conclusion for us. Okay. But we want an equation of log 10k versus 1 by t, so job is not done here. So to proceed further, I hope everyone knows the Gibbs Helmholtz equation, which is delta R G naught is equal to delta R H naught minus T delta R S naught, right? Where delta R G naught is change in Gibbs free energy of the reaction at standard state, where delta R H naught is change in enthalpy of the reaction at standard state. T is again temperature. Delta R S naught is change in the entropy of the reaction at standard state. Okay. Now we will substitute the value of delta Rg naught that we obtained from the previous derivation. So we'll substitute this as minus RT ln K is equal to delta RH naught minus T delta R S naught, right? Now they're asking us the graph of, you can see, log K versus 1 by T. So therefore, I will divide this whole equation by minus RT minus RT in both sides. Okay, so this will get cancelled. We are left with ln K. Nice. Here we are left with minus delta RH naught by RT. Here we are left with plus delta RS naught by R. Correct. dt gets cancelled, yeah, and minus minus is plus, yeah, cool. Now the graph is between log K base 10, log is base 10 versus 1 by T. So therefore we have one more thing, we have to convert this ln K into log K. We know that ln K is equal to 2.303 log 10 K. So therefore we can substitute this value here. So we have 2.303 log 10 K is equal to minus delta R H naught by RT plus delta R S naught by R. Cool. Now divide by 2.303, because we want the graph of log 10 K versus 1 by T. So dividing by 2.303 both side, so I get log 10k is equal to minus delta r h naught by 2.303 r into 1 by t plus delta r s naught by 2.303 r. Cool. Now if you look at this equation, this is in the form of y is equal to mx plus c, where your y is log 10k. The slope of the graph is this one, that is minus r delta h naught by 2.30 r. X is your 1 by t, and the intercept c is your delta r s naught by 2.303 r. So therefore m, or the slope of the graph, is going to be minus delta r h naught by 2.303 r, and intercept c is going to be delta r s naught divided by 2.303 r. So therefore this is the answer.